All right, in this video, we're going to be talking about probability and statistics. All right, so the first thing we're going to go over will be finding the mean, median, mode, and the standard deviation of a data set. Then we're going to go over the probability of a single event. Then we're going to go over combinations. Then permutations. And multiple permutations. And then finally, the probability of multiple events, multiple consecutive events. All right, so let's go ahead and just dive right in. So first, we're going to talk about the mean, median, mode, and standard deviation. So the mean of a data set is also known as the average of a data set, which written out, the formula looks like the sum I goes from 1 to n of xi all over n, which just means the sum of data points divided by the number of data points that you have. So for example, if we have a data set that has 1, 9, 7, and 4, and we wanted to find the mean of this data set, we would sum all the data points, so 1 plus 9 plus 7 plus 4, and divide that by the number of data points. We have 1, 2, 3, 4 data points, so we divide that by 4. And if you do the math on that, you're going to get 5.25. All right, so let's go ahead now and look at the median of a data set. That's also known as the middle number. All right, so what you're going to do first is order your data points from least to greatest. So using the same data set that we were using above, if we ordered those from least to greatest, we'd have 1, 4, 7, 9. Then what you're going to do is you're going to eliminate a data point from each side until we reach the middle. So we'd eliminate 1, 1, 1, 1. Now as you can see, there is no number left here in the middle. So we're going to take these two data points here and find the mean of those two. So 4 plus 7 divided by 2, which is 5.5. So 5.5 would be our median. Now, if we had a data set that was like 1, 1, 3, 3, 3, 4, 9, and we want to find the median. We eliminate 1 from each side, this side, that side, this side, that side, till we're left with 1 in the middle. And so for this particular data set, this would be our median. Okay? And then the mode is going to be the data point that occurs the most. So if we had this original data set right here, we have no mode because every data point only occurs once, so no mode. However, if we look at this data set right here, so we had 1, 1, 3, 3, 3, 4, 9. You can see there's 3 3s, and that has the most, so 3 would equal our mode. All right, and then finally, to find our standard deviation, we've got an equation. The square root of the sum is I goes from 1 to n of xi minus x bar squared all over n minus 1. All right, where xi is your individual data points and x bar is your mean of the data set. All right, so if we go back to our original data set of 1, 9, 7, 4, we found above that our mean is 5.25. So x bar equals 5.25. So we can find our standard deviation as being the square root of our first data point, 1, minus the mean, 5.25 squared, plus our next data point, 9 minus 5.25 squared, plus 7 minus 5.25 squared, plus our last data point, 4 minus 5.25 squared. And that's all over n, which is our number of data points, which is 1, 2, 3, 4, minus 1. Now when you plug that all in a calculator, you're going to get that your standard deviation is 3.5. And that's just how far away from the average your data points are landing. Okay? So let's go ahead and let you try one on your own. So find the mean, median, mode, and standard deviation. Of 2, 2, 3, 4, 1. Let's go ahead and pause the video now and then work it out, and you can check your answer with the PDF, and it'll be number 1 in the PDF. So now let's talk about probability of a single event. So to find that, your probability would equal let's see, possibilities, number of possibilities of occurring over total outcomes. And so something we can use for this is just the example of a dice. All right, so if we want to find the probability of rolling a 1 on the dice, number of possibilities of occurring would be 1, because there's only one side that has a 1, divided by total outcomes, total possible outcomes. So there's 6 sides on a dice. All right, so one side has the chance of being a 1 that's rolled, and then total of 6 possible outcomes. So that would be your probability. Now, if you want to know the probability of rolling a 1 or a 2, now we have 2 sides that have possibilities of landing on what we're looking for, divided by our total number of outcomes, which is 6, which would reduce to 1/3 as our total probability. So go ahead and try on your own. Let's see. If you're rolling a dice, probability of rolling an odd number. So find the probability of rolling an odd number on a 6-sided dice. Let's go ahead and pause your video, work that out, and you can check your answer with number 2 in the PDF. All right, so now let's talk about combinations. All right, so the nomenclature for combinations is going to look like C, parenthesis, N, comma, R. And so what this means, it's going to be the combination of N items taken R at a time. And the equation for this is going to be N factorial all over R factorial times N minus R factorial. Now, just really quickly, if you don't remember what factorials are, how you calculate them. If you, for example, had 5 factorial, that's going to be equal to 5, and then you just go down until you get to 1. So 5 times 4 times 3 times 2 times 1. Now, if you had 10 factorial, you'd start at 10, and then 9, 8, and so on until you get to 1. All right? So that's just a real quick review on how to calculate factorials. All right, so for example, if you are arranging pictures on a wall, and you have 10 total pictures, but can only place 2 on the wall at a time, how many photo combos can you create? All right, so this is going to be our N because that's our total number of items, and we're placing them on the wall 2 at a time, so that's going to be our R. So we're going to get 10 factorial all over 2 factorial times 10 minus 2 factorial. So that's going to be 10 factorial all over 2 factorial times 8 factorial. And then we can expand these. So we can go 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then you can start canceling things out. And we're just left with 5 times 9 on top, which is 45. So that would be our answer. All right, so go ahead now and try on your own. If you have 7 trophies, that need to be placed on a shelf. But you only have room for 3 on that shelf. How many combinations can you have? How many trophy combinations can you have? All right, so you can go ahead and pause your video, work it out, and check your answer with number 3 in the PDF below. All right, so let's talk about permutations. So that's written as P, N, comma, R, where you have R items being taken from a set of N items. All right, and so the nomenclature for that is going to be N factorial all over N minus R factorial. All right, so one thing to note about this is that your items aren't replaced. So for example, if we have 10 different colors of marbles, and you can only pick 3, you can only pick 3 colors, and you can't repeat colors. And how many arrangements can be made. So notice for this one, the colors can't repeat. So if you had 3 marbles, you could have a blue, a red, and a yellow, but you can't have a blue, and a yellow, because you can't have 2 blues, or you can't have 2 reds, or you can't have 2 yellows. All right, and so that's how we know that we're going to be using this permutation equation rather than the combination equation, because in the combination equation, we could switch out the different items. All right, and use them more than once. So we're going to have 10 factorial all over 10 minus 3 factorial, which is 10 factorial over 7 factorial, which is 10 times 9 times 8 times 7 factorial all over 7 factorial. So that's going to be equal to 720 different arrangements. All right, so go ahead now and try on your own. You have 10 different desserts. And you decide you're going to have 3 desserts. And you want all 3 to be different from each other. How many arrangements? Can be made? All right, so go ahead and pause your video. Try it on your own. Check your answer with number 4. All right, so now let's talk about multiple permutations. So this is going to be P of n, so your total number, and then event 1, 2, 3, so on until you have so many permutations. All right, and that's going to be equal to total all over each one multiplied by each other. All right, so for example, if we have numbered tiles, and we have 4 tiles that are labeled with the number 1, we have 3 number 2 tiles, and 7 number 3 tiles. And we wanted to find how many ways these can be ordered. All right, so first thing you want to do is we want to find n. So that's just going to be our total number of tiles, which is equal to 4 plus 3 plus 7, which is going to be 14. All right, so we'll just have 14 factorial all over factorials for each individual event. So 4 factorial times 3 factorial times 7 factorial. All right, so if we expand this, 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial all over 4 times 3 times 2 times 1 times 3 times 2 times 1 times 7 factorial. We can start canceling stuff out, so the 1's go away. And we can reduce that, bring that to a 4. We can reduce that, bring that to a 3. We can reduce that, bring it to a 2. We can reduce that. And let's see. 4, we can reduce that to a 3. So then if you multiply all that out, you're going to end up with 120,120 different ways those tiles can be arranged. All right, so go ahead and try on your own. If you had 3 A tiles, excuse me, 2 A tiles, 3 B tiles, and 1 C tile, how many arrangements could be made? All right, so you can go ahead and pause your video and check your answer with number 5. Okay. So now let's look at multiple consecutive events and finding the probability. So what you're going to do is you're going to find the probability of your first event and then multiply it by the probability of your second event. All right. So, for example, if we have a bunch of different cookies in a bag, let's say we've got 2 chocolate chip cookies and 3 peanut butter cookies. And you wanted to know the probability of pulling out 2 peanut butter cookies in a row. All right, so probability of the first event would be to pull out 1 peanut butter cookie from a bag containing 5 total cookies. And then the second event would be to pull out another 1 peanut butter from a bag, but now since we've already taken 1 out, we only have 4 total cookies left in there now. So the probability of this first event here is going to be, how many chances do we have of pulling out a peanut butter cookie? We would have 3 out of a total of 5. Now for the second event, since we've already taken 1 peanut butter cookie out, now we only have 2 chances from 4. So then we multiply these together, we get 6 over 20, which ends up being 3 over 10. So that would be our probability. All right, let's go ahead and try this on your own. Let's see, if you have 10 marbles in a bag, there are 4 red, 2 green, 3 blue, and 1 yellow. Find the probability of picking a red marble, then a yellow marble. Let's go ahead and work that out on your own. Pause the video and check your answer with number 6 of the PDF below. All All right, and that about does it for this video. So we went over probability and statistics. Go ahead and take the quiz, see how you do on it, and continue to do it till you get 100% on it. And you can do it in a timely manner.